quadratics two different ways. We are on our we've solved using the quadratic formula. The factoring method works if you can factor it. The quadratic formula works every single time, no matter what. Hi. Oh, you saw my calculus things.
Yeah, but they came out weird. Like.
Oh. You did not staple?
No.
That's fine.
And there's weird.
I can work with it.
I wanted you to have it.
Yeah.
Oops. You needed it for first.
Yeah. Yes. Thank you. Oh, you're fine. So we solve two different ways. Now this method is the square roots method. So problems could still be solved with the quadratic formula. Okay, they could still be solved with the quadratic formula. But if you are doing the problem and you recognize the term that has a plain x, then this method is a little bit easier. If you don't really like the quadratic formula, you can use this method instead, okay? So we're going to draw a little arrow up here. We're going to say use this method if b is missing. A could be equals 0. Do you have to use this method? No. Formula wanted. The quadratic formula is still valid. This is just another method, okay? So we had factoring, if it's factorable. We have the quadratic formula, which works every single time, no matter what. Quadratic formula always works, okay? This method works if the x term is missing, if b equals 0 in the quadratic formula, okay? So this does not work every time. All right. Actually, let's go ahead and get started. So this one is unique because it doesn't have to equal 0. This one happens to equal 0 when we get started, but it doesn't have to equal 0 when you get started. Your goal in this one is to get the x alone, okay? So the process that we're going to use to get x alone is we're going to undo all the operations that are around x, okay? And the way that we undo all the operations that are around x is we do order of operations backwards. Does anyone remember the acronym they use for order of operations? PEMDAS, or PEMDAS. Learn about it? No? I heard somebody in the back say it a little bit southern sound. I know. She immediately averted her eyes. All right, so you gotta embrace it. Don't be ashamed. Don't be ashamed. So if we do order of operations backwards, now some people think that because the acronym is 6 letters long, it's 6 steps. That's not true. It is only 4 steps. Okay. The first step is the P. The second step is the E. The third step is the M and the D at the same time. The fourth step is the A and the S at the same time. Okay, so it's actually only 4 steps. It's not 6. So when we solve equations, we do order of operations. If we're trying to solve for an x or for a variable, we do order of operations backwards. If you're trying to get a variable alone, you do order of operations backwards. So the first thing we would do is we would say, okay, is there something I could add or subtract to the other side that would help me get the variable closer to being by itself? So if you look at this problem, is there a number you could move away from the x by adding or subtracting? Yes, what could you do? Plus the 49. Okay, so what we're going to do is we're going to add the 49 over, plus 49, and we end up getting x squared equals 49. And Gina Wilson calls this isolating x, which is, that's what we're doing. We're getting the x all by itself on that side. The next thing you do is you say, is there anything I could multiply or divide to the other side to help me get x alone? In this case, there's nothing you could multiply or divide. But that would be what we would do next if you had like a coefficient, if you had like a 3 in front of the x squared or a 2 in front of the x squared, or negative in front of the x squared, or let's say it was x 5, then you could multiply the 5 to the other side, something like that. That's the multiply or divide step. The third step is the exponent. So you say, should I introduce an exponent to get rid of something, or should I do something to undo an exponent? So we have an exponent here we need to undo. How do we undo that exponent? We square root. So what I'm going to do is I'm going to write this right here. I got x squared equals 49. I'm going to square root both sides. Square root both sides. So when I square root an x squared, I get x equals, now when I square root 49, I don't just get one answer, I get two answers, plus minus 7. All right, somebody give me their favorite animal. Horse? Horse? Horse. Okay, if you do not put the plus minus, you are killing a little baby horsey. Killing a little baby horsey, that's what we're going to make. I haven't made the sign yet, but I'm going to make the sign. And if you do not, because it's not on the board, but it should be. So if you do not put the plus minus, if you are the person, remember we talked about this yesterday, if the radical is already there, then they've already chosen. If the radical is already there, they said they either want it to be positive or negative. But if you are the person who puts the radical in the equation, then it has to be a plus minus. If you're solving an equation, there's two answers. If you are the person who does the square root, there's two answers, plus minus. If I see you square rooting and not doing two answers, you kill a little baby horsey. Little baby horsey.
Yeah.
Whoa!
Would be worse.
You guys are sadistic. Majority rules and it's one person saying it.
I agree. That would be so sad.
I don't even know what a narwhal is.
Like the unicorn of the sea. A whale with unicorn.
Interesting. I have not. All right. Let's go ahead and solve some of these, shall we? Let's go ahead and solve some of these. All right. All right. Here we go. Let's do number 1. All right. First step. Can you add something to the other side to start getting x alone? Yes, what can you do? Add 16. You can add the 16. Is there something you could multiply or divide over to the other side? Nope. Okay. Is there an exponent you can introduce or an exponent you can get rid of? Yes. What can you do? Square root. Okay. And when you square root, what do you get? Plus or minus 4. Plus or minus 4. Okay. All right. Put a big old X through 3. We're not going to do that one. We're going to completely skip that one. We're going to, it's just not, we're going to come to it a different day. Put an X through 5. Okay. Yeah. We are going to get to those, but we're just not going to get to them today. It is imaginary. Did you guys do that last year?
No. We did all of this last year.
Did you do this worksheet?
No. I don't think so.
Not this particular one? Ah, so many problems. Why? Why you do this to us? All right. Okay. All right. Let's look at number 7. Let's look at number 7. All right. First step, can you add or subtract something to the other side? No, you cannot. Okay, so we're not going to do that step. Second step, can you multiply or divide something to the other side? Yes. What can you do? Divide by 6. Okay. X squared equals, okay. Third step, can you introduce an exponent or take away an exponent? Yes, take away an exponent by doing what? Square root. And when you square root, what do you get? Oh, we almost killed a little baby horsey. Which we did not, but we did not. The horsey was on the brink of death and then it was brought back to life. Whew. Macy was worried and then she was okay. It was okay. Whew. All right, let's look at number 10. Number 10. Is there something you could add or subtract to the other side to start getting x alone? What is
It's the 5.
the 5? So we add the 5 over. Okay, so we get 1/2 x squared equals d. And then, is there something you could multiply or divide over to the other side? Yes. You could multiply by 2. So you could divide by 1/2, but that's a little bit trickier than just multiplying by 2 to get rid of it. So 1/2 times 2, that just cancels out. And then 50 times 2 is what? 100, okay? Is there an exponent you could introduce or an exponent you could get rid of? Yes. Get rid of. What are we going to do? Square root. And x equals? Plus or minus 10. Okay. Let's do number 9, because this one looks very weird. Yeah. Okay. First step. Is there something you could add or subtract over to the other side? No. Is there something you could multiply or divide over to the other side? Yes. Do you guys want to handle the 3/4 in one step, or do you want to do it in 2 steps? One step? Okay. So do you want to divide by 3/4, or do you want to multiply by 4/3? Both are going to handle it. It just depends on what your comfort zone is. Okay, we're going to multiply by 4/3. Multiply by 4/3. That gets rid of it. X squared. So if you want to get rid of a fraction, you can multiply by the reciprocal. Multiply by the flipped version. 4/3 is 3/4. That's 12 over 12. 12 over 12 is just 1. 1x squared is just x squared. Okay. So we have, you can think of this 2 ways. You can think of it as 12 divided by 3 is 4. And then 4 times 4 is 16. Or you can do 12 times 4 is 48. And 48 divided by 3 is 16. Or you can say, Miss Rice, you're silly. I just did 12 times 4/3 on my calculator. And got 16. Okay. Okay, so we got 16. Do we have an exponent to insert an exponent to get rid of? Get rid of. And then what do? Root. And we get plus or minus 4. Okay. We had a lot of perfect squares on this side. I think we should flip the page over because I'm assuming probably I disagree with you, but let's do it anyway. All right. So first step, can we add or subtract something to the other side? Yes. Okay. So we're going to add the 16 over. So we get 9x squared equals 16. And then what should we do? Divide by, so multiply or divide is our next step. We're going to divide by 9. Okay. And so we get x squared equals 16 over 9. And then what should we do? Square root it. And what do we get? Oh, thank you for saving that little horsey. Jack is going to be over there killing horsies left and right. Killing horsies left and right. All right. Let's do number 19. Step 1, can I add or subtract anything to the other side? No. Step 2, can I multiply or divide anything to the other side? Step 3, is there an exponent to introduce or get rid of? Yes. What should I do? Square root. All right. X equals, and how should I write this answer? Yeah, plus or minus, don't little see. Okay, this is my exact answer. And whenever we have answers like this, we're always pretty interested in the approximate. So let's go ahead and find the approximate answer. X is approximately 4.359, negative 4.359. This again. Yep. Wow, what fun! So cool. Okay, okay. All right, I need to look at the sheet. I need you to tell me which one you guys want to do next. 27. Let's do 27. That's a good one to do because it looks hooray. Every single one. Let's do 27. Okay. So, first step, add or subtract. Now, we cannot add the 17 over. Why not? It is protected by those parentheses, and we know that when you go through all the steps, step 4 is to bust inside those parentheses, so we cannot get to step 4 first. Okay, so we got to add or subtract, but we cannot easily add or subtract something. We cannot get inside these walls, so we can't do that first. So we got to go straight to step 2, which is multiply or divide. So what could we multiply or divide? Yeah, and we're not going to distribute it because we're moving stuff away from X. We're not moving stuff towards X. Distributing it moves it towards X. We want to move it away. So how do I get rid of the 3/4? You can divide by 3/4, or you can multiply by 4/3. So we're going to multiply by the reciprocal. Yeah. So 6. You should not, because that's not helping you solve the problem. So 24 divided by 3 is 8. It's not wrong necessarily. It's just you're taking one step back before you take a step forward. Is there something inside the parentheses that we could add or subtract over to the other side? Yes. Now we can add the 17 over. Okay. Four? We don't need to do 4. We can do 4 is okay. 28? 18? 28? Okay. 28. Okay. First step. Is there something we could add or subtract over to the other side? Yes. What do we do? Minus 3. Okay. Is there something we could multiply or divide over to the other side? Yes, what is it? $64? $65? $64. Okay. Is there an exponent you could introduce or an exponent you could get rid of? You can square root. X equals plus or minus 8. We're not killing that horsey. Obviously. Obvi. I feel so hip when I say it.
Wait, can we do 23?
Yes. Yes. Okay, so if we look at 23, okay, so, 18 is one of the ones we put an X through. Sorry, we're not going to do that one. Yeah, put an X through 18. Because you were square rooting a negative? Yes. Yeah, it's one of the ones you put an X through. All right, so 23, can we add or subtract? Ooh. Ooh.
No.
Okay, can we multiply or divide?
Oh, right, I forgot that you can make it a
And then third step, you can probably reduce this, but I'm not going to worry about reducing it just yet because I know what's going to happen next, so I'm just going to leave it for a second. So the next step is to introduce or get rid of the exponent. So what do? Okay. So x equals, yeah, so we got 10 over 6 first, and then you can reduce that, right? And that's where the plus or minus 5/3 comes from. Yes, it just means you're sadistic. Okay. Do we need to do 25 or 26? Sure. Sure. All right, which one do we want to do first? 26. All right. So, what should I do first? Okay.
And then multiply.
Multiply by 5. Multiply by what? 5/4. Okay, so you can do 8 divided by 4 is 2. 2 times 5. Or you can do 8 times 5 is 40. 40 divided by 4. Or you can plug it in your calculator. What do you get? Okay. And then what do you do? We get x equals? Okay. And then we are interested in the approximate answer for this one because that was not a perfect square.
When I was doing the book things on my homework,
Mm-hmm.
they weren't like the same number.
It's because you were taking the square root and adding something to it, and this time we're just taking the square root, we're not adding to it. Yeah. Yep, nope, you were doing it right. Yeah, that's the difference between solving by taking square roots typically and versus solving with the quadratic formula. The quadratic formula will do that, yeah. Good clarification. All right. We still want to do 25? Because I tricked you that one time.
And now we're all like, let's do all of them.
It's funny because you're like, let's do all of them so we don't have to do all of them.
Yeah. Because like some of us are like this after school and like don't get home till late, and so Yeah.
Yeah, but by the time I have like 3 times this, it's already completely like provide all of it.
Bro,
That's what happens
to I got lunch and
So what you're saying is I broke your trust once, I broke it forever.
Yeah.
All right. So what do I do first?
Very true. Yeah, but the trust matters. And then if you multiply,
No, I didn't even like that.
that was kind of awkward too. She's like, she's like jamming out, and then we're just over here like 30 squares, 36 times.
I'm not trying to be fast.
Good job. Did you catch on that we finished 25?
Yeah.
Okay.
Yeah.
Okay. I have a punchline sheet for us. Whoa! We cannot hate on the punchline sheets. Because look, it says, it's what did the boy snake say to the girl snake, and they're in love. Well, look how cute! And that's important because then you have immediate confirmation on if you're doing it right. But that's good. None of that is bad. Bentley, hello! Bentley. All right.